All right, let's move into section or module 9, section 4 or lesson 4, which is graphing rational functions. So last time we did graphing um, reciprocal functions, and that's when we had a constant in the numerator and a polynomial in the denominator. Well, a constant is actually a polynomial. It's a one term or a monomial in that particular case, but it is considered a polynomial, so we've done it. It's just that that was kind of a special case. So we're going to go through a lot of different special cases when we go through this video. What we're going to do first, though, in this video is just really an introduction. So kind of what are all the different pieces and components of everything in these rational functions. So we have a to the x, or a of x over b of x. A of x is a polynomial, b of x is a polynomial. And what we need to do is we need to find a lot of information about this function to be able to graph it. So we need to see, is there a vertical asymptote? Is there a horizontal asymptote? Is there an oblique asymptote? What all do we have based on the information that we are given? So that's what we're going to kind of walk through. So the vertical asymptote we find by setting the denominator equal to 0. So of course the denominator can never go to 0. So therefore we set it equal to 0 to see what those values are, and those become my vertical asymptotes. Remember that a vertical asymptote is something like that. So we have a function that can never cross that particular line. And then we're going to figure out a horizontal asymptote. A horizontal asymptote would look something like this. And your horizontal asymptote is, again, just like the vertical asymptote, something that the function can never cross. And then we also have something called an oblique asymptote. And an oblique asymptote, and I know I don't have it written down here because in the regular lecture I didn't go through that. I want to make sure that I do that here. Even though on the test I won't throw it at you, but on the homework problems you will see it. And I'll go through one that has an oblique asymptote as well. But looking at this, we have our vertical asymptote, this one right here. We have our horizontal asymptote, this one right here. And then we could have an oblique asymptote, which would be something that is neither horizontal nor vertical. It's a line that runs through the graph that the function can never cross. So there is a possibility that we could have that line there as well. Okay, so we'll get to that. So I'm going to kind of write that a little bit later on. I know I have room on this page to be able to do that, so we'll do that. So to find the horizontal asymptote, so we know how to find the vertical asymptote, set b of x equal to 0. For the horizontal asymptote, at the most, we can only have one horizontal asymptote, so we will never have more than one. Now, a vertical asymptote, we could have multiple ones, but for horizontal, we can only have one. So if the degree of a of x is greater than the degree of b of x, then there are none. Now, how do we find a degree? So notice here, we have a polynomial. We look for the degree. The degree is always the highest power. So we look here, 5, 6, 8, 1. And this is really, if you remember what I've talked about, x to the 0. So that's a 0. So this is a 1 because that's an implied 1 there. And so if you look at the highest power, that's this one right here. So my degree of this function is 8. So that's what we're looking for. So we're looking for the degree of the numerator and the degree of the denominator. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. If the degree of a of x of the numerator is less than the degree of the denominator, then y equals 0, or the x-axis, they mean the same thing, is the horizontal asymptote. Okay, so this line right here, the x-axis, is y equals 0. If the degrees of both a and b are the same, then we're going to use this equation to figure out what our horizontal asymptote is. So what do? We look for the leading coefficient of the numerator, the leading coefficient of the denominator. We divide them, and that's our y equals. Okay, so looking at this here, what's a leading coefficient? So Leading coefficient, remember this is the degree. My leading coefficient is this right here. It's always the number in front of the highest degree. And it would be the -5, not +5, not just 5, but it has to include the sign. So it'd be -5. So that's the leading coefficient. So that's how we find the y value. We look at the leading coefficient of the numerator, the leading coefficient of the denominator. We divide those two numbers. As you can tell, it's probably going to end up being a fraction a lot of times. And then that's what our y equals, which means our horizontal line that goes across the graph. Okay, so those are two things. Now this is one that I left off, which is our oblique asymptote. So our oblique asymptote, again, is that line that would look something, similar to this. This is an equation of a line, right? So of course, for the horizontal, we have y equals something. For our vertical, we have x equals something, x equals something. So this is for our horizontal, this is for our vertical. And then our oblique is, again, just a line. It's just a separate line. So it's a y equals, some kind of y equals, mx plus b, something like that, some equation that we have for our oblique. Okay, and so how do we find that? Well, we have to divide. So what we would do is we would divide b of x into a of x. Now, the only time we have an oblique asymptote is if a of the degree of a of x, first off, has to be greater than the degree of b of x. And it only can be greater. Let me write greater down here, even though I don't have a lot of room. Greater by 1. So only if a of x is 1 degree larger than b of x. So let's say that, well, we'll take a look at some of these as we go through them. So let's just kind of walk through the first ones just to kind of get through at least one of them. So let's get through this one first. So notice here is that the degree of a of x is 3 because that's the highest degree up here. The degree of b of x is 1 because we got a 1 there. So notice that is 2 times bigger or twice as big or 2 degrees bigger than the degree of b of x. So there is no oblique. So I know I don't have it written down here, but let's do oblique is asymptote. There is none. Okay, remember that by the rules, if we have to look at the vertical asymptote, we have to set the denominator equal to 0. So for the vertical asymptote, we're going to set the denominator equal to 0. Add 4 to both sides. We get 8x equals 4. We divide both sides by 8, and x equals 1/2. So there is my vertical asymptote. Our horizontal asymptote says if a of x is greater than b of x, there is none. Even if it's only 1 greater, there is no horizontal asymptote. In this case, because it's 2 times bigger, or twice, not really twice as big, 2 more greater. I don't know what I'm trying to say. Anyway, it's greater, but it's not by 1. So therefore, there is no horizontal and there is no oblique. Okay, so what are our zeros? So how do I find our zeros? Well, same kind of concept as we found our vertical, except we're going to assign the numerator a of x equal to 0. So a of x has to equal 0. And when does that happen? When x cubed equals 0. When x cubed equals 0, x equals 0, right? Because we take the cube root of x cubed and we take the cube root of 0 and we get x equals 0. So that means that x equals 0. In that case, what we would then do is go plug it into the y Remember that our y is x cubed, so this is our y value. Y equals x cubed over x minus 8x minus 4. We're going to plug in a 0 there, so we get y equals 0 cubed over negative 0 minus 4, or just minus 4. 0 over anything except 0. Notice this is not 0 down here. This is negative 4 when we combine those together. Then y equals 0. So that means that we have a 0 at 0, 0. Okay, x is 0 and y is 0. Okay, so that takes care of the first one. We're going to go through and do some more examples now, just to really get you to understand, hopefully, what it is that I'm looking for.